Hello friends, welcome back. This is a probability equation. I think there's a 61% chance you're going to love it. Try it on your own, hit the pause button, and then we're going to do it together. Okay, I hope you tried this on your own. We're going to do it together now. We have to calculate what are the odds of all three of our friends being selected. To do that, we look at the first selection. The first selection, we have 10 possibilities, and 3 of them would work in the sense that 3 of them would be our friends. So in the first selection, the odds are 3 out of 10 that one of these 3 gets selected. Then for the second selection, we have 9 people remaining, and 2 of them are our friends. So the second selection, it would be 2 out of 9. And then finally, for the third selection, we have 8 people total because we've taken 2 out of the mix. And of those 8 people, assuming the first 2 worked in our favor, only one of them is one of our 3 friends. So the odds of the third selection being in our favor would then be 1 out of 8. We would have to have all 3 of these work. To calculate it, we would be multiplying the odds. So we would multiply 3/10 times 2/9 times 1/8. And let's do that right now. We could do a couple of simplifications. The 10 and 2 can simplify. The 3 and 9 can simplify because 3 goes into both of those. We would calculate everything. So we got 1 over, let's see, 3 times 5 would be 15, times 8 would be 120. So 1 over 120. That is the answer for the first part. So there is a 1 out of 120 chance that all 3 of our friends get selected in those 3 selections. Let's go to the next one, which states what are the odds that at least one of them gets selected. There's a few ways to do this. The way I did it is I looked at the odds of none of them getting selected plus the odds of none of them getting selected, which would be at least one of them getting selected, has to equal 1 because those are all the probabilities. Either none of them get selected or at least one of them gets selected. So none plus at least 1 has to equal 100%. So let's calculate what are the odds that none of them get selected. The first selection, there's 7 of them that are not our friends and only 3 that are. So the odds of the first selection being a person that's not one of the 3 is 7 out of 10. The odds for the second selection of it being none of our friends would be 6 out of 9. Because there's only 6 of our non-friends remaining, and there's only 9 potential candidates. Then we look at the third selection. The odds of the third person not being one of our friends is 5 out of 8. Because we would want all 3 of these to work to see what are the odds that none of our friends get selected, we would multiply these odds together. So we would multiply 7/10 times 6/9 times 5/8. We could simplify the 6 and the 9. We could simplify the 2 and the 8. And we could simplify the 5 and the 10. Calculate the top. We got 7, 1, and 1. So that's 7. And then the bottom, we got the 24. We have 7 over 24 equals the odds that none of our friends get selected. If you recall, we have to do the none plus at least 1 equals 100%. So that what we could do here is we could have 7 over 24 plus at least 1, which we'll call x, equals 1. And instead of putting it as 1, we'll just do the common denominator of 24. And 1 is just like 24 over 24. So we have 7 over 24 plus x equals 24 over 24. We subtract 7 24ths to each side. 24 over 24 minus 7 over 24 equals 17 over 24. And that's the answer. There is a 17 out of 24 chance that at least one of the 3 gets selected. And there you go. Please subscribe if you want to see the future videos. Keep on practicing these math equations. You'll keep getting better, I promise.